This lesson will show how to evaluate the given definite integral using the method of U-substitution. The first step is to recognize that U-substitution is required because the integrand function is the sine of 1/2 x, not just the sine of x. So here u is equal to the inner function of 1/2 x, and therefore differential u is equal to the derivative of 1/2 x times dx, which gives us 1/2 dx. And now looking at the integral, notice how we don't have 1/2 dx, and therefore we will solve for dx by multiplying both sides by 2. 2 times du is equal to 2 times 1/2 dx, giving us 2 du equals dx. So now we know we can substitute u for 1/2 x, and we can substitute 2 du for dx. And we need to remember right now the limits of integration are for x, not u. This is x equals 0, and this is x equals 2 pi. So now let's write this in terms of u. dx is equal to 2 du. We'll factor out the 2. And sine 1/2 x is now sine u. And now we need to make a choice. If we want to leave this in terms of u to evaluate, we need to determine the limits of integration for u using the equation u equals 1/2 x. Or we can find the antiderivative with respect to x and use the original limits of integration. In this video, I will show both methods. So I'm going to go down here and write 2 times the integral of sine u du, and we'll come back to this shortly. And now I'll show how to find the limits of integration for u. Well, when x is equal to 0, u is equal to 1/2 times 0, or 0. And when x is equal to 2 pi, u is equal to 1/2 times 2 pi, or pi. And now we can evaluate this, leaving this in terms of u. The antiderivative of sine u is equal to negative cosine u plus c. We leave the plus c off when evaluating definite integrals. So the antiderivative is 2 times negative cosine u, or negative 2 cosine u. Let's go ahead and factor out the negative 2. And now we determine negative 2 times the difference of big F of pi and big F of 0, where big F of pi is cosine pi minus big F of 0 is cosine 0. This gives us negative 2 times the quantity cosine pi is negative 1 minus cosine 0 is 1. Here we have negative 2 times negative 2, which is positive 4. The definite integral is equal to positive 4. But again, for this example, I also want to show how we could have determined the antiderivative in terms of x and use the limits of integration from 0 to 2 pi. So if we go back to the indefinite integral written in terms of u, 2 times the integral of sine u du, we already know from above, is equal to negative 2 cosine u plus c, which means the antiderivative in terms of x would be negative 2 cosine of 1/2 x. And here, because we have the antiderivative with respect to x, we would evaluate this using the original limits of integration, which are from 0 to 2 pi. And let's just show we get the same result. Factoring out the negative 2 first. We would have negative 2 times the quantity cosine of 1/2 times 2 pi minus cosine of 1/2 times 0, which gives us negative 2 times the quantity. Well, here we have the cosine of pi, which we know is negative 1, minus cosine 0, which is 1. And of course, we get the same result. Negative 2 times negative 2, which is positive 4. And I do like showing the second method occasionally because sometimes textbooks won't show the U-substitution. They'll show the antiderivative only in terms of x. And finally, before we go, if we take a look at the graph of y equals sine of 1/2 x over the closed interval from 0 to 2 pi, and shade the area bounded by the function on the x-axis, we have this purple area here. And because the area is above the x-axis, the value we found is equal to this shaded area. I hope you found this helpful.